So we're going to go on to conic sections. So in order to intro the conic sections, I would like to show you this wonderful video that we have about it. I want to go there because I want to full screen this thing. Sure, this is riveting on the if you're watching on the interwebs. Gotta restart it. There we go. I know. Stop yelling. There it goes. Now we'll crank some volume, and then we'll find this one. And then now we'll go boom.
Circles, parabolas, and ellipses. Oh my.
We see them all the time, and we've even worked with them before in math class. But what are they really? How can they even be grouped together? 2 words. Conic sections. Conic sections. What is a conic section? What are they used for? How are they made? And where do they appear in the real world? We'll look to answer all of these questions in our unit on conic sections. A conic section is created when a plane intersects 1 or 2 cones. What can result from this intersection is a circle when the plane is perpendicular to the axis and goes through one of the cones. An ellipse when the plane intersects one of the cones but is not perpendicular to the axis. A parabola when the plane intersects one of the cones but is not perpendicular to the axis. And a hyperbola when the plane intersects both of the cones. Depending on where the plane intersects with the cones, the size and shape of the conic can vary. See how the size changes as the plane moves around? Every type of conic, circle, ellipse, parabola, and hyperbola, has a specific equation that we'll cover in the coming weeks. Once we master the basics of conics, we'll move on to the applications of conics. But what are conics even used for? The applications of conics are everywhere. Conics appear all around us, in architecture, in physics, in optics, in astronomy, and in navigation. For example, when you are lost and use a GPS to help you find out how to get home, the GPS uses conics to locate your position, the position of your home, and the distance between them. Another example is in architecture. Both bridges and buildings use conics as support systems. Mirrors and lenses are concave in the shape of conics to focus light to a singular point, just like a lighthouse or a searchlight. Conics are also used to describe the orbits of planets, moons, asteroids, and satellites in our universe. In the coming weeks, we will master the basics of conics, learning the key terms and equations for each type of conic section. We will use the applications of conics to understand why conics are so important. And finally, we will end the unit by having every student create an image using the conics and equations we have learned in class.
Sweet! Yeah. a quick little intro on conics. We'll get into more and more of them as we go along. Like there's circles, there's parabolas, there's ellipses, and there's hyperbolas. Okay. So today, in order to begin that, we got to talk a little bit about distance and midpoint. Now you've seen both the distance and the midpoint formulas already. You did the distance formula back in chapter P. You did the midpoint in chapter P also. Okay? So this should be very quick. Again, here is the, why is it still not, why? Okay, there it goes. I don't know why it's still up there or why that's still large, but we'll make that go away. And there, boom, shabam. And then we can get rid of that. And here we go. Okay, so no matter where 2 points are, the distance between them is always subtract the x's, square it, subtract the y's, square it, add them together, take the square root of that. Okay? That's the distance formula. We talked about that a little bit in, I want to say that was in P3. Okay? All right, so we're good there. Okay? Okay? So find the distance between those 2 points. Well, if I'm going to find the distance between those 2 points, my distance formula is d equals subtract the x's, square it, add that to subtracting the y's, square it, and then take the square root thereof. So that's going to be, my distance is going to be -5 minus -3, so that's really -5 plus 3 squared, plus 1 minus 2 squared, and then take the square root thereof. -5 plus 3 is -2. Okay. 1 minus 2 is -1. -2 squared is 4. -1 squared is 1. So the distance between these 2 points is the square root of 5, because that is not simplifiable. Okay? And we would leave that in the square root of 5 unless we ask for something different. If we ask for the decimal equivalent of that, then give the decimal equivalent, but otherwise leave your stuff in radical fractional form. Okay? If you would be so kind as to find me the distance between those 2 points, that would be awesome. Down a little bit, might have to go a little extended page. So the distance here is going to be -5 minus -3 quantity squared added to 0 minus 2 quantity squared, and then take the square root of that. -5 minus -3 is -5 plus 3. That's going to be -2 squared. 0 minus 2 is also -2. That's going to be squared. I'm going to take the square root of that. That's going to be 4 plus 4, which is 44. Okay, right? 4 plus 4 is 44, isn't it? Yeah? Yeah? No, not so much? Oh, okay, so we'll just call it 8 then. Do I like the square root of 8? What do I like instead? 2 squared is a 2. Yep. So simplified radical form or simplified fractional form are always phenomenal. Yeah, buddy? Yeah, buddy. Okay. Midpoint. Okay. To find the midpoint, we just average the x values, we average the y values, and then we give our answer as an ordered pair. Okay? Remember, ordered pairs have a comma in between the 2 numbers, and parentheses on the outside. Okay? So it's an average of the two. Okay? Midpoint is the distances between the endpoint and the midpoint is the same on both sides. Okay? Again, I'm going a little speedy through this stuff because you've already learned this stuff. Okay? Find the midpoint of the segment joining those two. Well, I take the x values, -2 and 4, I add them together and I divide by 2. I take the y values, 3 and -2, I add them together and I divide by 2. Okay. -2 plus 4 is 2. 2 divided by 2 is 1. -3 plus, 3 plus -2 is 1 divided by 2, and I'm going to leave that in fractional form. FYI, we are big on fractions, not on decimals. Right? When in doubt, give it to us in fraction form. We're not scared of them. Okay? We'll save this people that are being scared of fractions for another class. Okay? Not in this room. Okay? Side note, Algebra 2 Extended had their room in here, or had their class in here yesterday. They want to take over the room. I said, not happening. This is our hood. Okay? All right? Circle of life. It's the circle of life. That's the only part of the song that I know. I heard it a bunch of times in summer, but that's the only part of the song that I know. Okay. Right? What truly is a circle? And don't say something that's wrong. Anybody know what the true definition of a circle is? I didn't expect you to know it. It is the set of all points here's the important word, equidistant. What's equidistant mean? Equal distance, so the same distance, okay? Equidistant, so the set of all points equidistant from one point. And that point we call the center. Okay? So I set, we'll do it in the orange. Okay? So I set a point. There's my point. A circle is, make sure we go in orange too. The set of all points that are equidistant from that point. So if I go over here and I say that this distance is the same as this distance, is the same as that distance, is the same as that distance, is the same as that distance. And I made myself a 2 5-slice pizza. Okay? Or a piece of pie if you want, either way. Okay? So that's what it is. Okay? So those distances, those black distances are all the same. Okay? The equation of a circle with a center at the point h, k and a radius r is x minus h, quantity squared, plus y minus k, quantity squared, equals r squared. That's the equation of a circle. Now, one thing that I will tell you, one little side note, if you will. In math, if it's inside a set of parentheses, you need to think opposite. Okay? So x minus h really corresponds here to positive h as a point. So if h was negative, inside this set of parentheses, it would be x plus some number. Okay? We're thinking oppositely when we're dealing with these equations. Inside a set of parentheses, we think oppositely. Outside, we think normally. Inside, we think oppositely. Okay? So, here is the equation of a circle. And you can just sketch the circle after we get it graphed. Okay? The first thing that we need to identify is we need to identify the center of that circle. Okay? So I need to find my h and my k. So here is this number and this number are where I'm looking at, because here's h and there's k in those numbers. So if they're inside a set of parentheses, so I'm thinking here that the center of my circle is at -3, positive 1. Do we agree with -3, positive 1 as the center of our circle? Okay? Plus, think opposite is negative. Negative, think opposite is positive. Okay? So then I go to that point on the coordinate system. -3, 1 is 3 to the left and 1 up from the origin. And for me, I put a C there, signifying center. And that's the center. It's truly not on my circle, but it's part of my circle. Okay? This number out here is my radius squared. Okay? Because that's from the formula, r squared. So the radius of my circle is going to be 2. I take the square root of that value, and that becomes the radius of my circle. Okay? What that tells me is, from my center now, I'm going to go in every direction. I'm going to go 2. So I'm going to go right 2, up 2, left 2, down 2, and all distances in between. Okay? So that my circle... Oh, don't act like you're not impressed. You may be thinking to yourself, that's easy, Shills, but that's not as easy as it looks. Okay? Yeah, don't sell me short. I'm a tremendous slouch. Okay? Alright? So there's your circle. Now, again, we are not artistical type teachers. Well, 2/3 of us are not artistical type teachers. Okay? Hill, on the other hand, she's all about, hers would be exactly perfect. Okay? But she's better than me. I've said that many, many times. Okay? So make them as good as you can. Okay? Right? If you want to use a compass, go ahead. I'm not going to stop you. Okay? Okay? Find both the center and the radius, then graph. Well, what's different about this one? There's something that's a little different about this one than the last one. Actually, there's a couple of things. Anybody see one of the things that's different?
You're multiplying instead of adding? Or instead of finding the opposite? Like you're multiplying the x and the center?
So there's coefficients on our squared terms. Yep, okay, so that's one thing that's different. And there's no parentheses, right? Okay, so those are a couple of things that are different. So, in order to do this, in order to find the center and the radius of the circle, it's got to be in that standard form. So the very first thing that I would have to do here is I would have to get rid of that coefficient in front of my squared term. Okay? So I would have to divide all of my terms by 7. Okay? Now, in a circle, those two coefficients on the squared terms, on the x squared term and on the y squared term, in a circle, those are the same. Okay? If they're not the same, it's not a circle. It's actually an ellipse. And we'll get to that next week. Okay? But if those two are the same, if the coefficient, that's the tell, is those two numbers, those two coefficients have to be the same in order for it to be a circle. Okay? So then my equation now is x squared plus y squared is, I want to say 16. Okay, 7 goes into 11 once with the remainder of 4. 7 goes into 42 6 times, so that's 16. Okay. So based upon that, now, where is the center of my circle? No?
On the point of origin.
Point of origin. So it's at 0, 0 because I'm adding or subtracting nothing inside this set of parentheses. The parentheses aren't even there, so those are zeros then. Okay? I could write this as x minus 0 and y minus 0. Okay? What's my radius? Well, yeah, 4. Okay, the square root of 16 is 4. So here is my center, 2 and 4 out there, 2 and 4 out there, 2 and 4 out there, 2 and 4 down there, and Shills, no offense, I'm going to cheat. Ooh, it's a little, see, that's one of the reasons why I don't like cheating either, because you get this funkiness where it's not really true. I mean, it's true vertically, but the picture's stretched out, it's spaced. Yeah, it's just not good. But oh well, I'm going to leave it. Because I can. It's a circle. Oh, hers is not a circle? Mine is an actual circle. It's just that mine, when we copied and pasted the graph in there, that it didn't match up. Okay? Write the equation of a circle with the center at there and a radius of that. Okay, well, the equation of a circle is, again, x minus h quantity squared plus y minus k quantity squared equals r squared. Yes? Okay. What is h? H is just 3. Right? What's k? -2. And what's r? Square root of 5. So that's going to look like x minus 3 quantity squared plus y minus -2 quantity squared equals the square root of 5 quantity squared. Okay. Where from my original problem, here was my k, here was my h, and here was my r. Okay. So when it's all said and done, this becomes x minus 3 quantity squared plus y plus 2 quantity squared equals 5. And that is my nice, pretty, neat equation of a circle centered at 3, -2 with a radius of the square root of 5. Good times. one last example that I'd like to get to. So now it says find the equation of a circle with the center at 2, negative 4, and it passes through the point 5, negative 12. Okay? So in terms of this, we're through that point, and then we're going through another point over here or somewhere else like that. Okay? So we have the center, which means then that this is H and this is K, correct? What do we just need? The radius. And how are we going to find the radius?
Plug the point in the formula and solve for the radius.
Nope. Even easier. Use the distance formula. Distance between 2 points, okay, is there. So we first need to find the distance. So my radius is going to be 2 minus 5, quantity squared, plus negative 4 minus negative 12, quantity squared. 2 minus 5 is negative 3. Plus, what is that, 8? So that's 9 plus 64, which is the square root of 73. Agree with that? Okay. So now we can go to our equation of a circle, x minus h here, so that's 2, quantity squared, plus y minus k, k is negative 4, quantity squared, equals the square root of 73, quantity squared. Move that down so the people in the back can see. So my final answer here would be x minus 2 quantity squared plus y plus 4 quantity squared is equal to 73. Yes,